In topic 3, our job is to carefully add probabilities together. This will be very much connected to the OR logical connector. It always means add. It could also be connected to the union of two probabilities. But in the end of the day, we are trying to find the total sum of two different probabilities, or three different probabilities, depending on how many things we want you to add. Now, there's two different scenarios that are going to happen. In any sample space that we create, if I was to just pick a handful of numbers, for example, 1, 2, 3, 4, and 5. Now, if I was to ask what is the probability that from these 5 different numbers, you would pick a number that is either, even or odd, we would be dealing with two completely separate groups of elements. In set theory, we had a way of drawing this and organizing this. We had a way of completely separating these ideas, as in every even number in that list is totally disjoint than every odd number in that list. There's no common elements. There's no intersection, and they stay very separate. Now, in the land of probability, we give this another special name, very important vocabulary word, and we call this mutually exclusive. Totally separate. This means the same thing that we're dealing with disjoint items. Now, in a mutually exclusive, totally separate thing, adding could not be more natural and without any real danger that you're going to add the same thing twice or somehow create some really weird adding. Now, there's 5 different things in total. I see 2 different even numbers. I see 3 different odd numbers up there just to organize my little sample space. So I would be totally okay just saying, well, the probability of even should just add to the probability of being odd. Probability of being even was 2 out of 5. Probability of being odd is 3 out of 5. These add up. This adds up. There's a 100% chance that you would pick a number up there that was odd or even. However, we can manipulate our asking to be a little bit less clear cut. I could ask, for example, that I'm interested in a number that is odd or a number that is greater than 3. And this isn't exactly two completely unrelated groups of things. There's a considerable amount of overlap here. And if I was to try and organize this logical statement, these odd numbers versus these greater than 3 numbers, out of all 5 here, I would create a set called the odds, and I could create a set called the numbers greater than 3. But, for example, where am I going to put the element 5? 5 is odd, 5 is greater than 3. So they have something in common. I mean, we're really not supposed to draw the same thing twice, especially not in a set diagram, and especially not in probability. So I'm just going to drag this over. I'm going to move a little bit much. I'm going to move that into the correct spot. As in, there happen to be 2 other odd numbers, and there happen to be Oh, I'm making a mess here. Sorry. Now, there's one number here that was an odd and greater than 3. Okay, that was the 5. Sorry, I just want to I'm trying to get myself confused here. There was still 2 other odd numbers, like the 1 and the 3. And there was one number that was still greater than 3 that we hadn't accounted for here, the 4. I'll even in a different color say that this was the, come on. The 5 was the only one that was both the 1 and the 3 and the 4. Or those are the elements, just so that I'm being very, very clear here of where I'm getting this numbers from. So had I not noticed this, I could have been misled. I could have accidentally said, well, I'll take the probability of the odd numbers and add it to the probability of being greater than 3. And on its own, there's a 3 out of 5 chance of being odd. On its own, there's a 2 out of 5 chance of being greater than 3. So don't these just add up to 5 out of 5? Is there a 100% chance that you're in this region, odd or greater than 3? And no, that's not true, because there was one element that does not fit these descriptions. Where did the number 2? The number 2 was not odd. It wasn't greater than 3. And there's some contradiction here. So when we're adding these numbers, we want to be really, really, really careful that we're not mixing them up in the wrong way, that we're taking care of it. Maybe you have to subtract from this, or maybe you organize yourself and say, well, I'm not going to just add them like that. I've already organized it, and I know that's only a 4 out of 5 chance because there was one number that's not odd or greater than 3. Now, in these situations where there is an overlap, where the ideas are not totally disjoint from one another, we have to call these not mutually exclusive. And this is when there is an intersection between 2 probabilities, an overlap, and the idea that you could add the same stuff twice if you're not careful. You want to be really careful with these to make sure that we get that straight. This is the kind of question where it is going to be incredibly powerful to draw a sample space. Let me show again 2 4-sided die. Because I could ask, what is the chance of getting an even sum or a sum of 7? I could also ask, what is the chance of getting a even sum or greater than 5? And these are both adding. We're going to add some probabilities, absolutely. But I do want to see all 16 of my outcomes. I want a way to organize myself here, almost over-organize myself here, so that I can see everything that's going on in my sample space. Here's one die, here's the other die, and if I look at what they're asking, sums. This one was also a sum greater than 5. On my sample space, I'm going to actually show different sums, as in 1 plus 1 is 2. Pick a different color. 2. This is what the dies add up to. So I could roll a 3, 4, a 5. I could roll a 3, a 4, a 5, or a 6. I could roll a 4, 5, 6, or 7. I could roll a 5, 6, 7, or 8. And now I can at least see all 16 outcomes, all 16 sums. Now, remember me saying we're going to be over-organized? Now I'm going to draw a Venn diagram so that I can see, is even sums totally exclusive than rolling a sum of 7? Here are all the even sums: 2, 4, 4, 6, 4, 6, 6, 8. Those are every even sum. 1, 2, 3, 4, 5, 6. There was 8 ways to do that. And totally mutually exclusive. Rolling a 7, which are completely separate parts of this sample space. Totally exclusive, totally disjoint. There are 2 ways to roll a 7. Now this is out of 16. Adding is very natural and safe. 8 plus 2 gives me a total of 10 out of 16 outcomes, and there's the chance of either rolling an even sum or a sum of 7. And because they were separate, I really did find the adding to be actually quite straightforward. Pretty user-friendly. Start again. What is the chance that we'll get an even sum, which I'll again do in blue, or something greater than 5? Now, as I go to organize this, here again are all the even sums. Boom, 8. But here are all the things that are greater than 5. 6, 6, 6, 7, 7, and 8. Now notice, I actually highlighted the same stuff twice, which we are not going to count twice to find the correct probability. But I'm going to organize all of that so that I can do this very, very safely. I highlighted the same thing twice, 4 times, because there was 4 ways to get an even sum that was also greater than 5. That takes care of these outcomes. There are still 4 other even sums. There are still 2 other ways to roll something greater than 5. And now, this is not exclusive. It was well worth the effort to organize this in a Venn diagram. A Venn diagram has the natural effect of already subduing our subtractions, already organizing them into nice, easy to use totals. And now when I want to take the total of these probabilities, which is, all of these numbers added up, I still have to remember this is out of 16. There's 16 outcomes in total, and 4 plus 4 plus 2 is the amount of adding we need, which is now 10 out of 16. Hey, same thing. 10 out of 16. We would have gotten into a great amount of trouble had we just said, well, there was an 8 out of 16 chance of getting even, plus 6 out of 16 chance of getting something greater than 5. And adding those numbers is not how we got 10. We did not just add up the basic probabilities. Because there was overlap, because they were not exclusive, only when it is mutually exclusive can you really just take the basic probability of rolling an even, plus the basic probability of rolling a 7, and then just adding them up without really too much danger. This is a big sample space section. Have fun.